Good morning, my dear students. Mr. Osama with you. Let's continue our curriculum, starting with Unit 5, the last unit in the Secondary 1 curriculum, speaking about the nuclear chemistry. We have two chapters here, Chapter 1 or Lesson 1, speaking about nucleus and the elementary particles. Chapter 2 speaking about radioactivity and the nuclear reactions. As we know before that the nucleus has main three elements or main three particles. The atom components contains the electrons surrounding a nucleus, and the nucleus inside the atom contains both protons and neutrons. The protons have positive charge and the neutrons have neutral charge, and the electrons surrounding the nucleus have negative charge. As we studied before, that the proton has a mass approximately 1,800 times of the electron mass. So the electron mass neglected when compared with a proton mass or neutron mass. Also, we studied before that the Rutherford discovered the nucleus, and the heavy nucleus which has a protons and neutrons inside it. We have three main parts in the atom, which are a mass number with a symbol A, atomic number with a symbol Z, neutron number with a symbol N. Mass number including number of protons plus number of neutrons. As I told you before, the protons have positive charge and the neutrons have neutral charge. Both protons and neutrons concentrated in the nuclei of the atoms, inside the nucleus of each atom. We have also atomic number, symbol Z, which represents the number of protons that equal number of electrons. Both protons and electrons are equal number in each atom. That's why the atom is electrically neutral charge. The neutron number with symbol N equal the mass number minus atomic number. For any atom, if we suppose that the atom has a symbol X, the mass number written here in the upper side, in the upper right or the upper left side of the element symbol, the symbol A represent the mass number. The symbol Z represent the atomic number, and symbol N represent the neutron number. So we have main two numbers here, the mass number and the atomic number, and the neutron number may be written or not. For example, let's take an example of aluminium. Aluminium element has 27 mass number, which means that aluminium atom has 27 protons plus neutrons. But the atomic number here, 13, that shows the number of protons equal 13 and the number of electrons equal 13, the number of positive protons inside the nucleus and the number of negative electrons outside the nucleus equal 13. We can conclude the number of neutrons which is 27 minus 13 equal 14 neutrons. So aluminum has 13 proton, 13 electron, and 14 neutrons. Let's take the isotopes and the concept of isotopes. What are the isotopes? The isotopes, they are atoms of the same element that have the same atomic number but differ in the number of neutrons. For example, we have a hydrogen atom. Hydrogen atom has 3 isotopes. Isotope number 1, called proton, has 1 proton and no neutrons, 0 neutrons. This is called proton. The other isotope of hydrogen contains 1 proton and 1 neutron. That I told you, the neutron calculated by subtracting the mass number minus atomic number. 2 minus 1 equal 1 neutron. The third isotope, called tritium, the third isotope of hydrogen, has 1 proton and 2 neutrons. 3 minus 1 equal 2. Each element around us has its specific isotopes in the nature. The hydrogen has 3 isotopes, and the copper has 2 isotopes, and so on. Oxygen also has its own isotopes. Let's take the atomic mass unit. What is the atomic mass unit that we have studied before? The atomic mass unit includes the number of protons plus neutrons inside the nucleus. That represent the mass number. How can we calculate the atomic mass unit? The atomic mass unit of elements can be identified in terms of the relatively atomic mass of their isotopes and the ratio of the presence of each. Let's take an example. Calculate the atomic mass of copper, knowing that it is found in the nature in the form of 2 isotopes. So copper has 2 isotopes, copper 63 and copper 65. The isotope copper 63 present in nature in percent of 69.09%, and the copper 65 present in nature in 30.91%. The atomic mass unit of copper 63 equal 62.9298. This is the atomic mass unit of copper 63, and this information will be given in the problem. The copper 65 contains 64.9298 atomic mass unit. To solve this problem, we have to multiply the atomic mass unit of each isotope by its percent. The atomic mass unit of copper 63 equals 62.9298 multiplied by its percent, like this, multiply by its percent divided 100, equal to 43.4782 atomic mass unit. In the other side, the copper 65, its atomic mass unit equals 64.9278 multiplied by 30.91 over 100. This is its percent in nature. The results will be 43.4782 and 20.069. By summation of these results, we will conclude the atomic mass unit of copper. And this number is the average number of atomic mass unit of the copper present in nature, and we use this number in many calculations. Thank you very much for listening, and I hope if you any ambiguity or questions, just ask me through WhatsApp group. Thank you very much and goodbye.